In this lesson, we are going to talk about textures. We have been using this cube for far too long and we want something else. I mean, it's a beautiful cube, but we need to add more to this scene. And we are going to add textures. But first, what is a texture exactly? Well, textures are based on images. That's true. And those images will cover the surface of the geometry. How they cover the surface of the geometry, we will talk more about this later. But there are many types and many different effects you can have with textures on your geometry. It's not just about adding a color to the geometry. We are going to discover the most used types, and we are going to use the door texture by Joao, sorry if I say it wrong, Paolo, maybe. So this is a very famous texture. It combines many types of textures to create that beautiful door. So if you like Joao Paulo works, you can just access his Patreon and you can buy him a coffee like this. And he's done great textures, so please do. All right. The first one we are going to see is the most obvious one. It's the color textures. We can also talk about albedo texture. It's almost the same thing. So you can say color or albedo. This will be just colors that will be applied on the geometry. There is not much to say about it. We are going to use this one. We also have alpha texture, which looks like this. In the alpha texture, so alpha texture is a grayscale image. The white part will be visible and the black part won't be visible. And if it's gray, it will be half visible or something like this. There is also the height or displacement, which look like this. It's also a grayscale image and it's going to move the vertices. If it's white, the vertices will go maybe up. And if it's black, it will go down, and if it's a perfect gray between white and black, the vertice won't move. I can show you with some drawings, as always. If I have a plane, let's say a plane something like this. So this is my plane. And I have subdivisions. Let's say those like this, and also on the, this is a hard part. Okay, like this. It will be fine. Well, I have a lot of vertices. I have one here, one here, one here, one here, one here. Let's add some more. There. So as you can see, I have enough vertices. By applying a height or displacement texture on that plane, the vertices will move, and they will move up or maybe down. And this one will barely move. This one will move a lot. This one will move down. This one won't move. Well, it depends on the texture. This one will move. This one, yeah. This one, yeah. This one, no. This one, yes. And at the end, instead of a flat plane, you will have something that looks like this. You will have relief like this. And this one will go up. This one will go like this and like this. And this one won't move. So you can create like a terrain or stuff like that, which is cool. All right, let's get back to the slides. Yeah, the problem is that you need enough subdivision. If you only have, let's say, one here, and one here, if you apply a height map on this, you won't see much. So you're going to need enough vertices. All right, we also have the normal. The normals looks like this. You can see that it's a normal when it's kind of a purple, bluish texture. The normal is really cool, and we are going to test this, but let's try to understand first. The normal will add details, but it's details regarding to things like light. It's mostly about lighting. The cool thing with the normal texture is that you don't need subdivision. With the 8 map, we needed a lot of vertices. With the 8 map, we can have this very simple plane, just like, like this, like this, like this, like this. Just one plane with 2 triangles, apply the normal on this plane and you will see details, and you will see a lot of details and very precise details. And the vertices won't move. So you will be able to see those details like this, but if you put the plane just like this, you will notice that it's still a plane. It's like luring, it's like magic. And I can't wait to show you this. It's going to be in the next lesson when we are going to use materials. It has better performances because you don't have too much vertices on your, usually better performances, because we don't have much vertices. All right, the next one is called ambient occlusion. It's also a grayscale images like alpha and the other one we saw. And it will add like fake shadows in the crevices. And you can perfectly see those where you have like an angle. This will add black inside that angle right here. So it's just to add details, to add contrast and just look better. But it's actually physically not right because it's faking shadows. But you might get some good, great results with that. The next one is metalness. The metalness looks like this. It's also a grayscale image. When it's white, it's metallic. When it's black, it's non-metallic. And that's all. This will be used to create things mostly like reflection. If it's metallic, well, we can see the environment behind us. If we look at the door, this door right here, and this part is metallic, we will be able to see what's behind. That's the idea. And we also have roughness that looks like this. It's gray. This part are a little closer to the white. It's also a grayscale image. It works a lot with the metalness. So usually when you see metalness, you also see roughness, not always, but most of the time. And it's about light dissipation. If you take, let's see, a carpet, it's rough. You can't see the light bounce on the carpet. So if we were to create a texture for the carpet, it would be almost all white. It would be white actually. But if you take something else, I don't know, like a metal sheet, and you want to create the roughness, well, it will be like really smooth because the metal is really smooth. Actually, if the metal has bumps, has been in the weather, stuff like that, it will be more rough. It's up to you. But the idea is to dissipate the light if it's rough, and to keep the light bounce, very precise light bounce if it's smooth. As you can see, it's kind of gray because there is a varnish on the door. All right. If it would be like a raw wood door, it would be almost black, but here it's kind of gray because there is a varnish on the, I hope it's varnish in English, on the door. And obviously the metallic part are also kind of rough because it's old, and as you can see, it's white here. There are many other types. All right, I just shown you the most used types of textures, and you can actually create all the texture you want. You can create your own texture. I'm going to talk about this later, but these are the main ones. Those textures follow PBR principles. What are PBR principles? Actually, it's mostly the metalness and the roughness. PBR stands for physically based rendering, and PBR is something really cool. The idea is that you have a lot of algorithm calculation that follow real life. So it's physical. They try to follow it's formulas that try to follow real life when it comes to light bouncing, to how you light up a texture depending on the metalness and the roughness to get a realistic result. So this is what's interesting. With PBR, the goal is to get a realistic result by using real life calculation, getting close to real life calculation. PBR is becoming the standard, which is great. because many software like Unreal Engine, Unity, Blender, probably C4D, I have doubt about it, but probably are following those PBR, and it's great, and 3GS obviously, and it's great because you will get a very similar result on those platforms with the same texture and same model. So no surprise. It's not like you take you have a render in Blender, you put it in 3GS, and it's completely different. No bad surprise like this. All right, I put 2 articles. As always, it's in the links below. Just open the links panel. It's from Marmoset, and it's great articles about the calculation behind those. It's really interesting. It's hard. I had a bad time understanding those. You don't need to understand those, but it's really interesting. So please read those articles if you want to know more. All right, how to load textures. So I already have my my cube and my starter running. If you don't, pause the video and get back to the video once it's done. How do we load textures? Hang on, we need to learn a few things first. The first thing we need to know is how to get the image URL, because you're going to put an image in your project, right? But how do we get this image URL so we can load that image? There are 2 ways of doing it because we are using Webpack. All right, this is very situational. It's because I set the Webpack this way. There are things that will work anyway, but be careful if you're using something else than the template I provide you. It might be a little different. Keep that in mind. And you can use the template I gave you on each lesson for your personal project. It's okay. All right, what you can do first. We are not going to use this technique, but so you can just look at what I'm going to show you and not doing it. But still, I want to show you that it is possible. I took an image from static textures. I took the color.jpg. We are going to load all of them. And I put it inside the src folder. We are going to use the static folder right after. This image, I can retrieve the URL of this image. Yes, I have trouble saying URL in English. By doing import, I can choose a name. I'm going to use image source from, and I will simply write the path, just like I did for the style, starting from the script.js file. So it's in the same folder as you can see on my left. So I can just write color.jpg, and I can log this just to make sure that it's working, and you will see in your logs something like this. It's not the same URL. As you can see, it's different. So we have our website, we have assets, images, and then an image. We can see the whole link. And if you do command click or control click, maybe you can do right click, open a new tab. As you can see, this is the image, and the name is completely different. This is due to Webpack adding hash to create a cache breaker. We're not going to explain all of this, but it's just working, and it's actually a bonus to have this dynamic name. So this is one way of doing, and I use this way sometime, but we are going to test another solution. I'm going to remove this like that, and I'm going to remove this image, and we are going to load the texture directly from, I'm going to put it at the beginning of the static folder. So it's the same one. I put color.jpg file texture inside the static folder. All right. What is that static folder? Well, it's really simple. Look at this. I refresh. I haven't done anything specific. I can just write /color.jpg. And as you can see, I have my image. In a way, it's simpler. And that's all. It's simpler. We don't have this strange name for the file, which is actually a bum, but we can do with it. It's not, it's a small feature, but at least it's clear that it's just color.jpg. Be careful, I didn't had to write static. All right, I just put the URL starting from inside the static folder. So for me, it's just color.jpg. And if I wanted to fetch those textures we are going to see a little later, I would have to write textures, door, color. And I don't need to write static. And we are going to use this way of doing because it's kind of simpler in later situations. We will also load models and stuff like that, and we will put everything inside the static folder, which is why we use this one. But if you want to use the src folder, please do. You will get the same result. All right, so how do we load the image? Now that we know how to access the image path, how do we load the image? We are going to load the image located in the static folder, and there are multiple ways of loading images. Hang on, it's very interesting. We will start by using native JavaScript. So this is the way we do in native JavaScript. I'm going to put everything at the start of the code. I'm going to set, let's say, a textures section so that I can keep everything in the textures part of my code. And I'm going to start by creating an image, and this is native JavaScript. I'm going to do const image equal new image with a I in uppercase. Sorry. So I created an empty image. All right, I didn't specify the path of my image, but I can use this image, and I'm going to do image onload equal fat arrow. And here I will just put a log, and I'm going to write image loaded. The idea behind this code is that when the image is being loaded, the function written inside the onload property will be triggered, will be called. And then we can simply change the path by doing image src. And here we can write the path to the file. And the path to the image file is going to be, so I can remove this one. It was just an example. I'm going to use the images inside the textures folder. It's going to be slash textures slash door slash, and it's the same name, it's color.jpg. Be careful, if you do a mistake here, it won't work. I save, and as you can see, while I refresh, I get image loaded. It's a pretty small image. I mean, it's okay. It's yeah, okay. That's a pretty fat image, but still we are running in local, so it's kind of fast anyway. But if we were using, like, let's say a bad connection with a bad bandwidth and it's a huge image, we just had to wait, I don't know, 2 to 3, maybe 3 seconds before seeing this image loaded log. All right, so I loaded the image. There are other ways of writing this, and we usually use add event listener. I use add event listener. If you don't know about this, don't worry, you can use image onload. You will get the same result. It's even more simple. All right, how can we use that image? So inside this function, we know that the image is ready. How can we use that image on our cube? Unfortunately, we cannot use the image directly. We need to convert it to a texture. Texture is Three.js, and it's just a class, all right? And you have great example here. Don't look at them because we are going to do all of this. And the idea is just you provide an image, and the image gets converted to a format which is more GPU friendly. It's something you can send to the GPU to create this WebGL render. You cannot just use that image. Do not worry, it's pretty easy. And actually, using the texture will enable more features that we will see a little later in this lesson. So yeah, let's create a texture. I'm just going to call it texture. Let's keep things as simple as possible. And we are going to do, we can remove the console log. We're going to do new 3.texture. And the only parameter we are going to pass is the image. So we provide the image to the texture class, and supposedly going to work. You can log it if you want, just to make sure that there is no error. And as you can see, I get a texture, which is great. It seems to be working. I'm not using this texture but I will shortly. And this is what we are going to do right now. So how can we use this texture? We want our texture, our door texture, to show up on my geometry. What we need to do is use it inside the material. So I scrolled a little. I have my material with the color. As you can see, if I change the color, I get another color. So it's the right material. And I need to use the texture on that material. But right now, I cannot do that. And this has nothing to do with Three.js. It's a JavaScript problem because I declared my texture inside a function. And I cannot use the texture outside of this function. This is native JavaScript. Look at this. Texture is not defined. I cannot use it because it only exists inside this function. This is called scope. It's called scoping. It's where you can use variables that has been created. If you do a scope error, you have to refresh by yourself. All right, what can we do? First solution, do not do it. I can take this old code. Don't do that. I will show you a better solution and put it there. And here I will be able to use the texture. All right, this is a solution, but having to move all your code inside a callback, it's called a callback function, will be a mess, especially if you have multiple textures to load. So let's not do this. All right, the other solution is to create, follow me on this. It's not that hard, but you have to follow me. We are going to create the texture outside of the function. It's going to be 3.texture like this. And I will use the image in here. So what you might think here is that we are using an image on the, creating a texture from an image, but the image isn't even loaded. And yeah, this is wrong, but it's valid. I mean, JavaScript is fine with that, and Three.js too. What we need to do now is tell the texture that the image has changed and to update itself once the image is loaded. So instead of doing the texture here with the console log, we need to say that, hey texture, the image has been updated. Update yourself with that image. And we don't even need to provide the image. It already knows about this image. So to do that, we can do texture needs update. Don't forget the S here. Needs update in camel case, true. You just tell, hey, the texture needs to be updated, and Three.js will update the texture accordingly. And that's all. We don't have any more scope, JavaScript scope issue, because the texture has been declared out of all the function, so we can use it inside the material a little later. And this is exactly what we are going to do. Go back to the material, so scroll a little. My material is here. And instead of the color, we can combine color and what I'm going to show you, but it's for the later lesson. So instead of the color, you're going to write map, not true, texture, like this. You save, and that's it. You have your texture. Congratulations, it's so much better than a red cube. All right, it's the start of great things. Cool. So this was one way of doing the whole process of loading an image and then creating a texture and then using this texture inside the material. What we are going to do now is use a texture loader, which is a Three.js class to load textures, and it's easier. I wanted to show you this process because it's good to understand what's going on in the back, all right, behind the scene. It's always good. So this is why I shown you this one, but right now we are going to use a more simpler version. I will remove everything. I mean, everything in the textures. So be careful, if you save now, you're going to have an error because we are using a texture inside the material. So don't save or refresh. Const, and we are going to instantiate a texture loader. And texture loader is a class you can see right here. Texture loader, and you have great examples that you can use. All right, it's exactly what we are going to do. So you create texture loader and you're going to do new 3 texture loader. I won't pass anything right now. And then you can directly create the texture, and you will see how fast it is by doing const texture. So it's the same name as I used before, equal texture loader. And we can use the load method to load the image. And all you have to do here is provide the path to the image, which is exactly the same. It's going to be textures door color.jpg. I save. And as you can see, everything is working just fine with only 2 lines of code. Yeah, it's faster. It's better. So let's use this one. It's easier, I meant. Another thing is that one texture loader can load multiple textures. All right, I always see my student creating one texture loader for each texture to load, which is my fault. I always forgot to explain this. But you can create one texture loader and use it to load dozens of texture. It works just fine. All right, one texture loader can load multiple textures, and we're going to do this just to practice. We can go a little further by providing 3 functions after the path. So right here, instead of putting everything here like in the same line and another function, it's going to be a mess. I'm going to add some line breaks, and I'm going to explain to you what are these functions. So you can create 3 functions. It's going to look like this. As always, I'm using fat arrows. Do as you want. Classic functions will probably work just the same. And we have multiple things happening inside those functions. The first one is the load. So let me check my example. Yeah, load finishing, load progressing, load error. All right. The first one is the load. I'm going to write, you know what? I'm just going to write load. The second one is about progress. And the third one is about errors. And I will write errors. Let's see the result. I have just load. All right. The progress didn't happen. I don't know what exactly, but I don't I don't recommend using the progress. It kind of never works. You won't have like a progress between 0 and 100%. I don't really know how to use this progress and why we would be using it. I will show you an alternative when you load a lot of files, but I never use this progress callback. The error might be useful if you don't know what's happening. Let's say I write color I write color like this. As you can see, I have an error. It's just a JavaScript error because the image couldn't be loaded. But I also have my error callback being called, which is why I have this error. If I change it, let's say I write something like this, I have this. So it's depend on you. If you have troubles loading an image, maybe you can just write the callbacks and see what's happening and figure out the problem. So this is cool. Maybe we can get rid of it. Yeah. This is just an example about the callbacks. I will remove them, make some room because we are going to have a lot more. The next thing we are going to see about loading images, which will also work with loading models and stuff like that, is the loading manager. What is the loading manager? Well, it's a 3JS class, so we can access it here. As always, you have a lot of examples. Please pause the video, read them. Maybe you will learn what you need to learn about it. The idea behind the loading manager is to mutualize the events. Right now, we are only loading one texture and we use one texture loader. It's fine. A little later, we are going to load models, fonts, many textures, and we would like to know the progress of all these loadings. We want to mutualize the events about all those loadings. It can be like to have a loader. We will create a loader together with the bar, filling up. And at the end, we know that everything is loaded and then we show the WebGL experience. To do that, we can use a loading manager. So how do we use a loading manager? It's pretty simple. What you need to do is const loading manager like this. So we create an instance of this loading manager and we write new 3 loading manager, just like that. I won't put anything here, and I will use this loading manager inside my loaders. So right now, all I have is a texture loader, and we will see other loaders later. I think the next one is going to be font loader. You will see why, a cool project. So I use this loading manager in the parameters of the texture loader, like this. If I save, oh, I have to change the color, sorry. It was an example about the error. But if I save, it seems to be exactly the same thing. So, okay, I just added something called loading manager. That's cool. The idea is that now you can be alert about events, about starting loading, about loading events, so each file being loaded, about progress and about error by doing this. So unfortunately, it's slightly different from the other way of doing. We have onStart equal and we send a function. So this is the function and I send the function inside the onStart property. I assign the function inside the onStart property with equal. And I will do the same. You know what? We are just going to write onStart. So we know it's exactly this function being triggered. And we can do that for the onloaded. We can do that for the onProgress. And we can do that for the onError, which is this one. Oops. Like this. Let me check. Yeah. I save. So as you can see, it's before using the loading manager inside the texture loader. I save. And I will unzoom a little. Yeah, like that. I get onStart and progress. For now, that's all. I don't get the onloaded, which is strange. Yeah, I don't know exactly why. Do not worry. We are going to use those later with a huge project with a lot of textures. So yeah, what we can do now is load more textures. Be careful. I'm first going to rename the texture. So do it with me, or you will have troubles. I'm going to call it color texture because we are going to load many more texture. So we can see that the loading manager is working. So I rename it color texture. And because I renamed this variable color texture, I have to change in the material. All right. Do it. It won't work if you don't change it here. So I had this texture. Now I rename to color texture because I'm going to load. So I can save. Right. It's working. And we are going to add more texture just to practice and see how the loading manager is handling all of this. So I'm going to do it for the alpha texture. Let's test. So I have onStart, onProgress. Then I have the height texture, which is also a JPEG file. So I can just do it like that. And I think I can just change each one. Yeah, see, it's going to be normal. We're going to test those. Ambient occlusion with 2C. I hope it's right. Metalness. Maybe I forgot one. It's a good exercise, even if it's just a writing exercise. And roughness texture. Yeah. I save. Oh, I have an error, which is interesting because as you can see, I wrote roughness wrongly, which is this one. Yeah, I forgot the H. And my events got triggered well. We had the onStart. We had many onProgress. We have had 6 onProgress. And then we add an error. So we can see that there is an error. Actually, we can also use parameters here to get more information about the progress and stuff like that. So yeah, let's fix the roughness. Roughness, something like this, I think. Yeah, so we now have onStart and then 7 onProgress. And you can get more information, but we will stop right here for this part because we are going to use it in better exercises. If you're curious, you can see the normal texture instead of the color texture. As you can see, I have the normal texture instead of the color texture. This is not the way of using a normal texture. We are going to learn how to use this texture in the next lesson. So get back to the color. All right, we have to talk about UV unwrapping. I like UV unwrapping, but it's not for everybody. So what is UV unwrapping? What you can do is test other geometries. So I put them inside the text below, but you can just change the class and the parameters. So me, I'm just going to copy and paste. You don't have to do it. It's just an example I want to show you. Let's see what we get if we use a sphere. As you can see, I have a sphere, which is great, but the textures seem to be stretched, and it's really stretched in the middle and not that stretch on the top and the bottom. All right, let's see another one. I'm going to use a cone. Yeah, I can remove this. Same thing here. On the top, it's not that stretch. We have this really strange pattern. And at the bottom, it's stretch. And oh, I get my door on the bottom cap. Okay, interesting. Let's use the torus. You know, it's the donut. And as you can see, I have a different result. And yeah, it's all stretched along the thing. It's kind of repeating itself. That's interesting. All right, why I want to show you this? It's about how the texture is placed on the geometry. It's not random. It looks like someone decided that the texture has to put this way on the donut, this way on the sphere, this way on the cone, and it's exactly the case. So I will get back to the box buffer geometry, and we will talk about this, which is called UV unwrapping. UV unwrapping, it's like unwrapping an origami. I hope we can say origami. Or a candy wrap, like you got a beautiful candy, Christmas candy, I don't know, for your birthday, something like that. And when you unwrap it, you get a square. It's just a paper, a square paper. It's the same idea here. Each vertex will have 2D coordinates on that square. It's not necessarily a square, but usually we use square. I created some pictures to explain this. This is our cube. Yeah, let's go full screen. This is our cube, and we unwrap the cube, so we get a 2D version of the cube, and these will have UV coordinates. So this will be 0, this will be something like 0, 1, this will be 1, 1, and this will be 1, 0. All right, I have another picture for you. It's going to be this one. It's an old model I did quite a long time ago. You have also this sword, and the sword gets unwrapped, and you can do cuts. Actually, you can do cuts anywhere you want, and you will get this result. So as you can see, the handle is getting there, the blade is getting there, this rock is getting there, and each vertex. So let's take, I don't know, let's take the vertex right here at the edge. It is getting there, also there, also there. This vertex here is getting somewhere over here. All right, so you get your model. 3D model with 3D coordinates for each vertex, and each vertex also has a UV coordinate, and UV coordinates are 2D because it's on a plane. All right. We can actually see those UV coordinates because when we use the box buffer geometry, so it's a buffer geometry. If you remember from when we created our own buffer geometry, we can access the attributes by doing this. Geometry attributes. Maybe we didn't, oh no, we just use set attributes, and set attributes will, attribute singular, will update this object. And as you can see, so I can remove those things. I will just comment them. The loading manager thing. Now that everything is working, I can comment this. So all the callbacks on start, on loaded, on progress, on error, I commented them. You can do the same. It's just to have less inside the console. And then I log geometry attributes. And as you can see, I have many attributes in here. I have the position. You remember the position. When we created our own buffer attributes, we provided those position and we choose a name which was position, singular. And we also have normal. We will talk about normal later. What we want here is UV. And we can access those UV. So maybe if I write attributes UV, I get this. It's a float 32 buffer attribute with a lot of coordinates here. So we have 48 coordinates, and it's 2 by 2. item size, it's 2 by 2. It's not like the position, it's a UV, so it's 2 by 2. It's like a vector 2, meaning that the first vertex will have those coordinates, the second vertex will have those coordinates, UV coordinates, the third one will have those coordinates, and it goes on and on and on. And these coordinates will help position the picture, so the texture, on the geometry. Yeah, it's huge. Actually, it's a lot of work everywhere. Like everything is merging together. Those UV coordinates are generated by 3GS. So it's the guys that made those geometries that decided that the UV coordinates of this vertex will be here. The UV coordinates of this vertex will be here. All right. So huge thank you to those guys. If you create your own geometry, you will have to specify those UV coordinates. And if you're using a 3D software, you will also have to specify those coordinates, which is what I did for this project. I unwrap it by using Blender, all right? So this was just so you know about this. We are going to use UV coordinates quite a lot in different situations. All you need to know now is that the texture gets placed on the geometry in a very specific ways because there are UV coordinates set up inside the attribute. This is what you need to know right now. We also need to talk about transforming the texture. Because yes, we can transform the texture, which is great. It's part of the 3Texture class, 3GS texture class. So I will remove this log, the log on the geometry. This is another subject. It's transforming textures. So yeah, first we can repeat the texture. We are going to focus on the color texture, and I will write it, let's say, after loading all these texture. We're not going to use them anymore. It was just to explain that the loading manager was working well. And we are just going to apply those transformation on the color texture right here. So first we can repeat, and to repeat it, we can use color texture and the repeat property. The repeat property is just a vector 2. It's 2D coordinates. Wrong window, get back here. Yeah, I have so many things open. So it's just a vector 2, which means that we can access an X and a Y properties. Cool. Let's use the X, and we are going to do the same as the example, which is 2, and the Y we are going to use 3. Let's see how our texture repeats. Oh no, it's not working as expected, but we have an interesting pattern because this is just the half of the whole thing, and in terms of 8, it seems to be like 1/3, which match what we said here. The result is that the last pixel, so the pixel on my cursor right now, is repeating to the right. And the texture on that pixel here is repeating to the top, which might be interesting. It depends on your project, but the result is kind of strange. Yeah, we can do quite cool things with that, but we won't talk about it. We can fix that by using color texture, and it's going to be wrap S for the X and wrap T for the T. I don't know why S and T, I have to check this out, but wrap S, and you can use 3, repeat, wrapping, and then wrap. So you can just let the S, and as you can see, it's repeating here. So we have cute doors, mouse doors, and we can do the same on the T with the same value, repeat wrapping, and you get this. All right, so we have 6 doors, which is interesting. Another interesting thing is that you can add mirrored repeat wrapping instead of repeat wrapping, and you get a very similar result, but it's mirrored, meaning that 1 on 2 will be mirrored. So you get this. Why not? Maybe it's for teething, so it's repeat seamlessly. I don't know. I never used this one. I never had to use this one, but maybe you will have a project where you need it. All right, we also have access to offset. We are going to just add the offset and then remove the repeat to understand more clearly. The offset is also a vector 2. We start to know how to use those. Offset, so we have access to the X, and I can do 0.5, and look at this. As you can see, I have a 0.5 offset on my texture. It's not on the whole UV, it's just on the texture. If you remove the repeat and the mirror, as you can see, we have an offset right here. And I can do the same on the Y, and we get something like this. And if I just add the mirror repeat wrapping, I get something like this. Oh, it's getting interesting. We have something like a crate. Why not? It started from a door and now we have a crate. We can rotate this texture. I'm going to add, I can let all of them. And I'm going to rotate from texture rotation. So rotation, it's not a vector 2 or something like that. It's not about axis because we are just on a 2D space. It's just rotating inside that 2D space. So you can just provide the value, let's say 1. So color texture rotation 1. And as you can see, I get something like that. Those are radians. Yeah, we talk a lot about radians, so we can use math pi. And actually, I'm going to do some drawings to explain this. So I will try to make a circle. Okay, that's not bad. So we have our circle, we have those axes. Let's say that it's starting, I'm going to use the purple one, yeah. It's starting, let's say here. If I want to make, let's say half a circle, like this, I'm going to use pi. So it's math pi. If I want to do, let's say a full circle, like this, oh, it's bad. Like this is going to be pi multiplied by 2. All right. I'm going to remove it because it's really ugly. And if you want to make, let's say, 1/8 of a rotation, like this, it's going to be pi. It's going to be pi. I use multiply 0.25. Or pi divided by 4. It's the same result, like this. All right, let's try to do this just for the sake of the lesson. And yeah, I already put the result here. I should have hidden this part. It's going to be math pi multiplied by 0.5, or you can divide by 4. I prefer to multiply. I don't know why, because I like to do always one way. So if I want more, I multiply by more than 1. And if I want less, I multiply by less than 1, which is why I always use multiply. And as you can see, I have a perfect 1/8 of rotation like this. Okay, cool. Cool. It's a long lesson. Hang on. Yeah, what you can do here is remove the repeat and the offset. And as you can see, it is rotating, but it's rotating in this point. All right. It's doing a rotation like this. And I don't like this. And I can change this. Actually, I want to make another drawing so you can understand really what's happening here. This is my cube. All right. It's the same for a plane. And the rotation occurs on this part. All right. It's doing a rotation like this, which is why I get this result here. It's rotating right here. If I want to do a rotation, let's say in the middle right here, and have something, so it's not right here, so it's not a plus. Yeah, like that. I have to move this pivot point to the center, and it's exactly what we are going to do. And we are going to move it by using the center. Yeah, I forgot about this one. We have to do color texture, center, to control where is the pivot point, and we are going to put it in the middle, and it's going to be, it's a vector 2. So it's going to be x 0.5 and y 0.5. And as you can see, it's rotated here in the center. It's rotated here. So sorry, it's not exactly the center, but you get it. It rotated on the center because I added 0.5 and 0.5. I'm going to use this. So it was 0.5 here and 0.5 here. Let's write them. It's going to be 0 0.5 and 0.5, which arrive right here. I know I'm not very good at drawings. All right, these were just transformation. You can do transformations. If you need it, use them. And we're going to use them, we are going to use them a few times. Let's talk about filtering and MIP mapping. This is a pretty hard subject, but we can do a lot with those, and sometimes we need those things. If you look at the cube, I can comment these, all right? So we get them not very far, but comment these. If you look at the cube like this, you get these top faces, and you put the camera right on the edge. As you can see, the texture is blurry. This is good, actually. This is a good feature. What's happening here is filtering and MIP mapping. And we need to talk about filtering and MIP mapping. The MIP mapping, you can also write MIP space mapping. I don't know which one is the right one. I see both in a lot of tutorials articles. Is a technique that consists of creating a half smaller version of a texture again and again until we get one by one texture. So again, we need to draw some things. This is we are going to use a square texture. All right. When using the MIP mapping, so we have a lot of pixels inside that texture. It looks like this and like this. Cool. When the MIP mappings occurs, it will create a smaller version, which will look like this. And it's exactly half. And then it's going to create a smaller version, which is the half, and then a smaller version, which is the half, and then a smaller version, half, until we get to a 1 by 1. This is MIP mapping. So at the beginning, we have a lot of pixels. Then we have half pixels in the height and in the width. Then half the pixels in the height and the width, and half the pixels in the height and the width. And those textures will be sent to the GPU. Don't worry, you don't have to do this. This is all automatic. You just provide a texture and the MIP mappings occurs, which is really great. Those textures will be sent to the GPU. And the funny thing is that actually it will be one texture, which will be, usually I think it's like that. So this is your main texture that looks like this. It's going to be half of our texture. Of our final texture. And then the MIP mappings will be here, and the rest will be set like here, 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 and you get a very strange thing where everything is put inside that texture. So it's something like that. And we don't have to do this, fortunately. And why do we need this? Well, the GPU will use different versions depending on how much of the pixel we can see. And this is what's happening. When I see a blurry texture, it's because the GPU is using one of those small versions, and it's actually better. And you will see why is it better. There are two types of algorithm to use those MIP mappings. The first one is the minification filter. The minification filter happens when the pixels of the texture are smaller than the pixel of the render. A good example, look at this, I put myself here and I zoom out and I get a very small picture. The texture is much bigger. Remember the texture, actually I have it here, so you can see that it's a huge texture that gets squeezed into that small area inside my render. So it's very small. This is where the minification filter occurs. All right, this is the case. We're going to see the opposite after, which is when it's like that. But now we are talking about this. When we have something like this, well, we use maybe this one, or maybe this one, or maybe a smaller version. And we can change how those pixels are getting fetched by changing the min filter property. Hang on. So what we can do here is on our texture, we are going to play with this min filter. So we are going to do color texture, min filter, equal, and we can use different algorithm. The default one is linear mipmap linear filter, and it will actually merge those it will take some of this and some of this and merge them. We are not going to see all of them because the difference is very small. We cannot see much of a difference. But if you're not happy with how blurry the result is, you can just test the others. We are just going to test the nearest filter, which has a very different result. And you can just use min filter equal 3 nearest filter. And the result is something like this. I don't know how it's going to look inside the video because I'm using compression. I can close the console to see more clearly. Maybe open it back, change it. I don't know what you're seeing exactly because of the compression, but me, what I'm seeing, it's like really sharp. Test on your screen and I get a really sharp result. It might be better. It might not be better. It really depends on the visual result you want for your project. So yeah, this is the nearest filter. And we are going to test another texture, which I put inside the same folder. So keep the nearest filter, like here, and change the texture to another version. And we are going to use the checkboard 1024, and it's a PNG file. Careful, if you just change the name, it's not going to work. And it's not inside the door, it's inside the texture folder. So write this path, save. And as you can see, whoa, what's happening? If you zoom, you can see that it's just small squares. See at the bottom here, it's small squares. But once the pixels of the texture are getting too small, we get this very strange result. And this result is called moire pattern. I think it's moire in French, like you say it, moire patterns. And it looks like this, and it's actually really cool. Like I think you can do a lot with those moire patterns and have fun and create psychedelic things. I hope it looks great on your on the video once compressed. Test on your screen anyway. This was the minification filter, and we can also play with the magnification filter. So it's the opposite. Should I keep this texture or not? I forgot. Well, the idea is it's exactly the opposite. I will use the door texture just to show you. You don't have to do it because we are going to test another one. But the idea is that when you have a texture and the texture is not big enough, so this is a big texture, but we are going to test with a very small texture right after, what you get is a blurry version. We cannot see it a lot right here, especially with the video compression, but still the texture gets blurry. So it's the opposite. This is minification filter when the texture is too big for the space it takes. And this is the magnification filter when the texture is not big enough and the pixels get stretched between the pixels of the render. What we are going to do is test another texture. So the path is check. I'm going to copy it. It's much simpler like this. So it's checkerboard 8x8 PNG. So write this. And as you can see, it's an 8x8 texture and it gets blurry. Maybe you're thinking that it's bad. I can show you the texture actually. You better see the texture first. The texture looks like this. So it's very small, sorry, but we get the same strange things here. It gets blurred when stretched. Actually, this is good because when your texture is just a little too small, the user won't see the difference because the pixel will get blend with other pixel. It will be stretched a little and your users won't even notice that those textures are being stretched like this and it's a little blurry. So usually it's good. But when you want to go for a Minecraft style of results, like I put some textures, some Minecraft texture here. So this one is blurry, but you get the idea. We don't want it to be blurry. So we get this Minecraft style. We need a solution. And the solution is as simple as the min filter. We are going to use mag filter like this. And we have two possible values. So the default one is nearest filter. And we are going to use nearest filter. I can command the min filter because we don't need it right now. And I'm going to use the magnification filter with the mag filter property with the nearest filter value. So it's a constant actually. And as you can see, it's sharp, like really sharp. And we can see the edges. There is no blurry version between the black and the white, which might be a better result for you. It really depends on your project. We can use the Minecraft texture right now. So change on the color texture as always, change for Minecraft.png. So I tried to create a cool texture. It's not that bad. And it's diamond block. And as you can see, everything is sharp. If we had the linear filter, it looks like this. Imagine Minecraft with this. It's more like PlayStation 1 games. Nearest, yeah, that looks great. So cool. We can keep this one for now. Yeah, one more thing. Using nearest filters is better for performances. You will get a better frame rate when using nearest filters. So if you don't care about the result, because I don't know, it's an object in the distance or something like that, use nearest filter, you will get better results, a better performances and a better frame rate. One more thing, when we are using nearest filter on min filter, which is the case here, so I uncommented this part, we don't need MIP mappings. Remember the MIP mappings? This whole process that creates a smaller version, smaller version, smaller version. We don't need MIP mappings when using the min filter to nearest filter. So instead of letting 3GS and the GPU handle those MIP mappings, we can deactivate them. And it's exactly what I'm going to do here. Color texture, generate MIP maps, and we are going to switch it to false. And as you can see, no error, but the MIP maps hasn't been generated, and we are only going to create this version of the texture, which is much smaller. It's just going to be that size, not this whole size. All right. Not this. Smaller textures on the GPU is better. We are going to talk about this later. Okay. So I repeat, if you are using nearest filter inside the min filter, you can deactivate the generate MIP maps and gain performances. We are almost done here. Let's talk about texture format and optimization. We need to think about three things. When we are creating our texture, fetching from the web, creating them in Photoshop, using them, we need to remember three things. The weight of the texture, of the file, the size of the image, so it's the resolution, and the data we put inside that texture. So we start with the weight. The users will have to download the textures. When you have a lot of textures on your experience, well, a user with bad connection and bad bandwidth will have to wait longer. And that's all. All right. So let's try to keep the weight of the files as low as possible, as light as possible. You can use web images like JPEG. JPEG is lossy compression, meaning that the image will get slightly different. You might see artifacts, especially if you compress a lot, but the file will be much lighter. Usually, depends on what you have exactly in it. If you are using PNG, it's lossless, so you get the exact values. It's not always exact values. We will talk about this later, but you get the right value. But the file is heavier, so you have to choose the right one, but try to keep the file as light as possible. You can compress JPEG and PNG by using any software or website. I personally use TinyPNG. I like this one. You just drag and drop your image in it. So I can take my door like this. And I get a compressed version. I can download it. And as you can see, I gain a lot. It's 5 times smaller. So yeah, you better use those kind of things. But it will apply a compression and it might look a little worse. All right, so you have to test the result and see if it fits your needs. Oh, and by the way, there are other types. One is called Basis. We are not talking about this. It's a very special, it's a lossy compression actually, but you get like really small files, and it's better for the GPU. All right. It's called Basis, B-A-S-I-S. But it's too complex for us. We are beginners. Let's keep things simple. So the second important thing was about the size. So yeah, obviously, if your image size is smaller, the file will be lighter. All right, but there is something else about the size. When you send, when you are using textures inside your WebGL experience, those textures will be sent to the GPU. And the GPU has limitations. You cannot send like huge textures and hundreds of huge textures to the GPU and hope everything will work just fine. You have to manage your GPU. You have to be nice with him and provide small textures. So yeah, just resize those textures so that they can be as small as possible. My color door is probably way too big. Maybe I will get very close to the door. In that case, okay. But if the door is just some houses in the back of the render, in the back of the scene, I can use much smaller textures, and it will be good for my GPU. Yeah, and don't forget that when using meat mappings, the images are something like twice as, you have twice as much pixels to store to the GPU. Yeah, also, because we are using meat mappings, we need to use textures resolution that can be divided by 2. So it's gonna be power of 2 resolutions. Why? Because when I have this texture, I'm going to divide, the meat mappings will divide it by 2, and again by 2, and again by 2 until 1. And if this number cannot be divided by 2, it won't be possible. If you have something like a float, you will get a bad result. And actually, if you do that, Three.js will resize your image, so it will take more time. The image will look bad, and so that the meat mappings can occur. So just always use power of 2 resolutions, and you can have a different resolution between the width and the height. All right, so. Let's use this one, 512. You can divide it by 2. I get 256. You can divide it by 2, 128 divided by 2, divided by 2, 2, 2, 2, 2, 2, until 1. All right? Because 512 is a power of 2. It works with the other numbers right here. Keep that in mind, and you will get an error if you don't do that inside the console. Three.js will do the resize, and you will get a bad, you will get worse performances and a bad result visually. So yeah, the third thing is about data. First, texture support transparency. If you want to use, we're going to do that. We are going to use a PNG file, and this PNG file, we have transparency, and we are going to use it inside the color property of the material. And you will see that the transparency will work, which is good. It's great. We can have transparent images and use them in Three.js, send them to the GPU, and get transparency in our material. So this is great, but be careful. Sometimes it's better, like in this case, to have a color version and an alpha version. It depends on the results. It will mean more to send to the GPU, but less to load. So you have to find the perfect balance and decide if you're going to put a PNG with transparent or 2 JPEGs. It really depends on the project. If you are using a normal texture like this one, you need the exact coordinates for the pixel. We are going to explain this later, but data is stored inside those pixels, and it's like orientation, and we don't need blurry orientation. We need the exact orientation, which is why normals are usually PNG, because PNG is lossless. You don't get a compression, and you get exactly the pixel value. So this normal is wrong. I did it on purpose. I changed it to a JPEG. I compressed it by using JPEG. So we have only JPEGs, but normal are usually PNG. it's not mandatory. You can have a JPEG for normals, but you might see strange results and artifacts on the light, stuff like that. Maybe we'll have opportunity to see these. And yeah, and finally, sometimes you can combine different data in one texture by using the red, green, blue, and alpha channel separately. I'm going to show you a website I did. It was for Immersive Garden. Great studio. Don't hesitate to have a look to their portfolio and their projects. And this is Chartering Télé. I'm not going to showcase the whole website. What I want to show you is those, we say blason, I don't know the English word, écusson, blason. As you can see, it's an image inside like something of a mask. We have a border all around the blason, and we also have a shadow at the bottom. So we have three things. We have this mask for the image, we have a border, and we have this shadow. I could have created 3 images. Instead, I did this. It's one image with the blue corresponding to the border, the red corresponding to the image, and the green corresponding to the shadow. And I used them in different meshes, in different ways. And for each one, I said, I'm going to use the blue to create a mask for the border. I'm going to use the red to create a mask for the image, and the green to create a mask. It's always masking actually, for the shadow. All right. We don't know yet how to do all of this. We will learn together these kind of things. Another one I can show you is the terrain, because as you can see, we have this terrain. So it's a huge terrain, and we have elevation in this terrain. You see that this one is lower than this part. And we also have alpha. See, at the edges, it's not like a sharp edge. We have alpha. It's disappearing. It's fading on the side in every direction. What I did is I use a very small texture, very small. I don't need it to use a big texture. I tried with a smaller. Smaller would be look bad, so I didn't get smaller. But it's quite small, so it's fast to load, and it's not much for the GPU. And I use the blue channel to save the elevation of the terrain, and the red channel to save the alpha. And I get this, and I did this inside Photoshop, and that's all. All right. It's long. It's a very long process, but it can really improve performances and the result and the GPU, etc. So yeah, the difficulty is to find the right combination of texture formats and resolution. And you have to spend time on it, because if you don't, we'll get performance issues, and you will have to go back to every texture you use in a project. It can be a bum. Finally, where to find textures. It's the end of the lesson. You did it. It was a huge one. I hope it was interesting. So where to find texture? I won't lie to you, I'm bad at this exercise. Me, I always do just searches on the web, and I usually end up in those 3 websites, but there are probably other websites. What I recommend you is to check the link at the bottom of the page. If I find more resources, I will add them. All right. So it's maybe not in the video, but check the links, and you will get maybe more links to find more resources, more textures. So it's Polygon. Some are free, some you have to pay, but the quality is usually much better if you pay, obviously. Sometimes it's worth to pay for it. And yeah, you have a lot of textures on those websites. Please check them and maybe use them. Do researches, do on Google or anything. Just write a door texture, and maybe you will find what you want. But keep in mind that if it's for personal usage, well, use whatever texture you want. But if it's for professional purpose, or you want to put this thing online, you have to have the right to use that image. All right. There are licenses, stuff like that. Make sure you have the right to use the image. And finally, you can also create your own textures. You can take photos. You can use 2D softwares like Photoshop. And you can even create procedural textures with Substance Designer. I really like this software. It's to create textures with nodes, and you can get awesome results. So yeah, have a look at this, and that's all for the lesson, I think. Yeah, we learned a lot. We learned a lot of theory here, but we are going to apply those in the next lesson. We are going to create materials and use the normal map, the alpha, and see what PBR results we can get. So don't worry if it was a lot to take in one shot. It's going to be much logical after the few lessons right after.